Good morning, everyone, and welcome to this session. This is lecture number 5, and we are dealing with static friction. And I think we should be over with it soon. In the last class, we had seen how do we find out the static friction in different cases, and we had seen that static friction being smart friction, it can change its value. It can change its value from a minimum value, which can be 0, to a maximum value, which is fixed, which is known as the limiting friction. Once the applied force increases more than the limiting friction, no one can stop that body, but the body will move. As soon as the body moves, the friction becomes kinetic, and I have told you that kinetic friction is always less than static friction. Whenever we are saying that the kinetic friction is less than static friction, is because it is less than the limiting friction. Remember, whenever static friction is being applied on any body, we don't know the value of friction because it can range from 0 to maximum. Therefore, as soon as your static friction comes, you must be careful because we do not know how much is this. Then we had seen this particular question where we had to find out the condition for which the block will move along the surface. I had shown you the condition where the block was pulled, and I had shown you under what condition the block will move. This is exactly the same question that came in this year's paper, the last year's paper. And then I asked you to solve the question when the block was not pulled but pushed. So anyone was able to get the answer for that one? When the block was pulled, that question where the block is pulled. Yes, anyone could do it. Anyone tried to do it? Anyone tried that question? No one, as expected. No one tried that question, so you will have to do it now. So now you will have to do that question and tell me the answer. So I have already done case number 1, and case number 2 is for you when the block is kept like this. And that was the question I think that came in this year's JEE, if I'm not mistaken. Yes, pushing wala question came in this year's of JEE. So now you have the time to tell me under what condition this block moves. You have 2 minutes to do it. Please do it. Remember, JEE is cleared here in the classroom and not in the examination hall. Same question might come in your JEE again. Must be prepared for it. 2 minutes you have. Yes, anyone with any answer? A block of mass m rests on a horizontal floor which has a coefficient of static friction mu. It is desired to make the body move by applying the minimum possible force F. Find the magnitude of that force and in which direction it has to be applied. So you have to find out the value of theta and F. Anyone remembers how did we do the last one? Shall I do it if you can't do it? How many of you tried this question at home? No one. Great. You had 2 days off and you did not try even a single question. Well done. Chalo, there is no point of giving you any more time because I don't see any answer coming from anywhere. Everyone is sitting and chilling out. So how are we supposed to do this? We are supposed to draw the free body diagram of this body. The weight mg goes down, normal reaction goes up, and then I will have to resolve this force. F is equal to mg is like this, so I can resolve it into two components. One component becomes parallel, which is trying to pull it. That becomes mg sine theta, and one component becomes downwards, which is mg cos theta. Now, since this block is going to move, is trying to move like this, friction force would be upright and friction force would be in the backward direction, and the friction force would be static in nature, Fs. This block is not going to move in the vertical direction, so from there I can get W equation. W equation is N is equal to mg into 1 plus cos theta. In the previous question, same question, everything was same. You don't even remember that question. Waste of time. That means the entire last class was wasted. Congratulations for wasting your time and mine as well. Anyways, you can see in the previous question, everything was same. Instead of getting NSMG into 1 plus cos theta, we were getting mg into 1 minus cos theta. Anyways, waste of time, waste of money, waste of resources. Anyways, we are Indians. We have this habit of wasting things. So we are in the same spirit that makes us the greatest country in the world. Waste resources. Okay, so n is equal to mg into 1 plus cos theta. Now the value of static friction can go up to the maximum limit, and when this maximum limit is less than your force, the block will remain stationary. If your force becomes more than that maximum limit, the block will move. So let us find out the maximum value of static friction, Fl. Fl is equal to mu multiplied by n. So this is mu mg into 1 plus cos theta. Now this is the limiting friction. This is the limiting friction. If your force is more than the limiting friction, your block will move. Which is the force which is trying to move the block? This is this force, which is mg sine theta, which is trying to move the block. So this friction must be less than or equal to that force, or your force must be more than. Oh, I've written it in the reverse order. This friction force should be less than or equal to your pulling force, or your that force should be greater than or more than this one. to solve this, and I guess you can solve this. Again, you will have to convert this cos theta, 1 plus cos theta into half angle. It in the previous case it was 1 minus cos theta, that was equal to 2 times sine square theta by 2. This time it will be equal to 2 times cos square theta by 2. And here you have to convert the sine theta into 2 times sine theta cos theta. And once you solve it, you will end up with this answer. Your tan theta will be greater than or equal to mu. That is the result that you will get. Once you get the value of tan theta, you can find out the value of this force. This force, once you know the value of tan theta, you know the angle at which this force has to be applied. That was what you're supposed to do. And that was the exact question that came in the last year's JEE. This was the exact question. Even the language is exactly same. But what's the use when we are not going to do any questions at home? We are going to waste time, no use. Whatever happens, what's IIT? Why should I go to IIT? The only thing that we are here is to prepare for IIT. We're only preparing for IIT. We do not aspire to go into an IIT. We are preparing for IIT. So congratulations for the preparation of IIT. And that would give you enough confidence that you can do something else. Or rather than going into an IIT, you're preparing for an IIT. Congratulations, everyone. Best of lucks. But since I am still aspiring for you students to get into an IIT, so I'll keep on my mission intact. I know your mission is not there, you have got no aspirations, but still, I will have to keep my thing going. So I will keep it. I will keep that thing going. Okay, this is a question. In the previous question, we were given the value of that force. Okay. Now I will present another type of question. Which is this one. Congratulations for all those who are preparing for IIT. It's real, no aspirations for getting into one. So, welcome IIT Prince. And this is the question for you, for all those who are preparing for IIT. A book of 1 kg is held against a wall by applying a force F perpendicular to the wall. If mu s is 0.2, what is the minimum value of force F? And I hope all of you IIT aspirants, preparators, would be doing something with this, because since you are in the class you have to prepare for IIT because that's a compulsion. So 2 minutes you have to solve this question. Anyone? Could get anywhere near this question? Anyone has any idea what you have to do? No? Okay. Then I'll draw the free body diagram, and I hope that from that you will get some idea of what is supposed to be done. Anyway, since you have not done any practice for the last 2 3 days, the chances of you doing this question is absolutely zero. Chances cannot be negative, otherwise I would have called this a negative. There is a chapter in your maths, if you ever get to that stage, called probability. I don't think it has started, and I don't know how many of you will be remaining till that chapter comes. Anyways, looking at what is happening right now, I don't think we will get to that chapter where probability will be taught to you. In any ways, there's a chapter called probability, and in that probability chapter, we study what is the probability of something happening. Now, the probability cannot be negative. The minimum value of probability is zero. And looking at your faces and how you have performed and how you have not done any practice for the past 2 days, the probability of this is zero. So there is no point of wasting my time. My time is important if yours is not. So the probability of this is zero. So I will, without wasting any time, I will draw a free body diagram. This is the wall against which the book has to be held. It's a very simple question. The book has to be held against the wall. How I'm going to hold the book against the wall? This is the wall. Ting ting ting. Smooth. This is the book. I have to hold it. How am I holding it? I'm pressing it like this. See? I'm holding it by pressing it like this. I'm holding it by pressing it like this. This is the question. What should be the minimum value if I make my force less? The block falls. What is the minimum force that I need to apply to keep the book on the wall? That is the question. This is the book, my dear friend. Book has a mass m. The only thing that I know that I have taught you, if you remember, so you might not remember because you're only IIT aspirants. Someone who was really wanting to go into an IIT would remember that we draw something known as a free body diagram. So this is the free body diagram. The weight mg is trying to pull it down. There is a wall, so there is a normal reaction coming from the wall. Ching. But I'm also putting a force on this wall so that I can hold it. This is the force that I'm putting on the wall. Now, I don't expect that you know, since you are only IIT aspirants, what is stopping this book to fall? From where I see, I don't see anything that is stopping this book from falling. What is stopping this book from falling? Anything? I don't expect you to know anyways, since you're only IIT aspirants. Yes? Anyone?
Force.
Yes? Yes, beta? What is stopping this book from falling? As I can see, weight is going to get it down fast. What is stopping this book from falling? This book has this book is supposed to not fall, is held against a wall. What is stopping this book from falling? No one knows it. As expected. Static friction. This book is not falling because of static friction is stopping it from falling. So that's it. That is what you have to find out. Now, how do you go about it? The book has to remain like this. If the book has to remain like this, it cannot go jig jig up or down. So your static friction, the blue equation, your static friction should be equal to mg. And this book cannot move like this also. So comes the green equation. Your normal reaction must be equal to the force. So your F must be equal to the normal reaction and your static friction must be equal to mg. But remember, the static friction is not fixed. It can vary. It can vary from 0 to a maximum value. That means the static friction has to be less than or equal to your limiting friction. But the value of this limiting friction is constant. Does anyone know what is the value of this limiting friction? No one knows it?
Mu Kn, sir.
Mu Kn. Okay, I'll write it. Mu K into N. What does K stand for?
Mu SN.
Oh, mu Sn. Chalo. Okay, mu Sn. Mu Sn. Now, so I can write this equation number 1 in a different way. Mg, which is the static friction, should be less than or equal to mu s multiplied by n. This is a very simple inequality. So mg should be less than or equal to, as you can see, your n is equal to f mu s into f. So your f should be greater than or equal to mg divided by mu s. It should be greater than this value or it can be equal to this value. I had to find out the minimum value. So from this equation, inequality, you can find out the minimum value of friction, not friction, minimum value of this force. What is the minimum value of this force? F minimum, since force has to be more than a certain value, the minimum value becomes mg by mu s. And that is the answer, dear, that we were looking at. I'll give you 2 minutes to note it down. I know you are good at noting. Please do it. Has everyone noted it? Great. That takes us to the next question. And these type of questions are pretty common in JEE. So this is the question that is coming for you. Question number 3 or 4 or whatever it is. There is a chain, uniform chain. That means the mass is distributed uniformly. There is a uniform chain of length L, and the coefficient of static friction is mu between the chain and the tabletop. So I'm supposed to put a chain on a tabletop. What's the big deal? I can put it. Calculate the maximum length of the chain which can hang from the table without sliding. So that is what you have to do. You just don't have to put it on the table. You have to hang some part of it from the table. What is the maximum length of the chain that you can hang without the chain slipping? What on what factor does will it depend on? If on what factor? If the chain is very heavy, you will not be able to hang anything, literally. What is going to stop the chain from falling down? Anyways, I'll give you time to think about it, to solve it. What will stop the chain from falling down? What will try to pull it down? Can anyone tell me that? If I hang the chain, what will try to pull the chain down the table? What? God knows, sir. What do we know? We are small kids. Just because our parents said go and prepare for IIT, that is why we are sitting here, sir. Hi, what do we know?
Force.
Huh?
Gravitational force.
Gravitational force. Oh, so, hello. Some there is some light at the end of the tunnel. When we were in our college time and we were having our final vivas, a lot of nice questions came up, and obviously we are all dumbs, apart from me, everyone else. So our director was taking our vivas. You know viva? Oral exam, viva. And he was asking all sorts of revolutionary questions, and our batch was giving all sorts of revolutionary answers. All sorts of revolutionary answers. He asked one of the students draw the bed plate of a main engine, and he threw something, some artistic thing, and he put it on his study table wall. And he said, I will get this design of you patented for this bed plate because this is the most revolutionary design that I've ever seen. Anyways, so during those vivas, he got rejected a lot, and then he told us this famous line, which I always keep on telling students. Our college was called MERI, but previously it was called DMAT. It's one of the most premier institutes of marine engineering in the country. DMAT is a dark tunnel. When you come into our college, DMAT is a dark tunnel. You don't know where you are going, but at the end you will cross that dark tunnel because at the end of the tunnel there is some light. So similarly, I can just see one or two small bulbs in the tunnel that we are going through. Preparing for JEE is just like a long tunnel. You don't know where you're going, but there are some lights somewhere that you find. Okay, light is there. We'll get to the other side. So, what we have learned from this philosophical lecture is gravity will try to pull it down. So, what is going to stop it? That is the next question. Is there any other bulb remaining in the tunnel? Or all the bulbs are gone? Gravity is the thing that is trying to pull it down. So, what will stop it? So, we won't stop it. We will allow it to fall down. Don't blame us. We are not going to stop it. Who is going to stop it? Not even God. God's hand or God's hair or God's anything will not stop it. Yes. Who will stop it?
Static friction.
Static friction will stop it. See, there is one more bulb that is lit up in the darkness of the tunnel. So, two bulbs are there and the tunnel is not so dark now. So, can you tell me what is the maximum length of chain that can hang from the table without slipping? And how you got to do this? Now you understand what is trying to pull it down and what is trying to stop it. You do what we have been doing all the day long. I mean, I think I have around 20 classes for Newton laws of motion, and in all those 20 classes we have been doing the same thing, same thing, same thing, same thing, same thing, same thing. I think you can do this. There's a famous story about Dhobi, washerman, and his donkey. The Dhobi takes that donkey every day along the same. The Dhobi goes and washes clothes on the ghat. You know ghat, the river bed. So he puts all these clothes on a donkey and he walks the same path every day. 5 days, 10 days, 15 days, 20 days, 1 month. And then one day he just puts the cloth on donkey's back and donkey reaches the ghat. Moral of the story? Moral of the story is not who is donkey and who is the dhobi. Moral of the story is if you do same thing many times, you should be able to do it the next time. We have been doing it the past 1 month. So I think you should do it again. You can do it again. So that is the hint that I had to give. The dhobi and the donkey story. A revolutionary one. Anyone with an answer? Anyone had drawn the free body diagram? Because as soon as you draw your free body diagram, oh, you will get your answer straight away. Anyone with a free body diagram? Anyone has drawn free body diagram? Can I have a raise hand? Anyone who has drawn a free body diagram of this? I can see a few small lights at the end of the tunnel. Can anyone show me the free body diagram? What we have drawn? No one. So now no one comes. No one has drawn the free body diagram. So if no one has drawn the free body diagram, there is no chance that you are going to get anywhere near this question. So this is how the free body diagram looks like. I hope now you can find some light in that tunnel that we are going through. Y part of this green part of the chain is hanging down, and this pink part of the chain is on the table. Something is trying to pull it down, something is trying to stop it. Something which is trying to pull it down, you don't see it in the diagram. Something which is trying to stop it, you can see it in the diagram. So now I'll give you 2 minutes. I hope that with this diagram you might be able to do some magic, create some magic from somewhere. Abracadabra. Gilly 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 gilly. Okay, so how am I supposed to do it? As you can see, the weight of the chain is on the floor, the part of the chain which is on the floor, which is the pink part. This is the weight of the chain. The total mass is m. So I find what is the mass per unit length because it is a uniform chain, and you multiply it by the length of the chain which is on the table. Length of the chain which is on the table is L minus Y. You multiply it by G, that becomes your weight of the chain which is acting downwards, which is on the floor. Then this normal reaction which is coming from the tabletop, that will be equal to this weight of the chain. So that is the first step of solving this problem. Do we understand this, how I've done this? Okay, now we have to look at what can be the maximum value of friction. What can be the maximum value of friction? Okay, before going into that, we have to also see what is trying to pull this chain down. This weight of this part is trying to pull the chain down. How much is the weight of this part of the chain which is hanging? The length of this chain which is hanging is y. What is the mass of this part? So it will be total mass m divided by total length L multiplied by y. Y is the length of this portion multiplied by G. This is the force which is trying to pull the chain down. The green part. This is the force which is trying to pull the chain down. Something has to stop it. What is going to stop it? Is our old friend. Static friction is going to stop it. So here the pulling force must be equal to this force so that it remains at rest. So basically what equation are you going to get from this green thing? This one combined with this one. You will get your static friction must be equal to m by L into y into G. That is the value of static friction. But you must understand that this static friction is always less than or equal to your limiting friction. Remember, whenever there is static friction, you don't know the value of static friction. It's less than or equal to limiting friction, but you know the value of limiting friction. The value of limiting friction is always equal to mu s into n. So now you put them into an equation. What is the equation that you are going to get? M by L yg should be less than or equal to mu s into n. And the value of n you already know. So now you can put them together. M by L yg should be less than or equal to m by L into L minus y into g multiplied by mu s. Some terms will get cancelled, gg, ll, and from here you can find out the value of y. Y will be coming less than or equal to a certain value. So the maximum value you will get by equating this. Whenever you get any question where they ask you maximum length or maximum mu or minimum theta, it's an indication that this maximum or minimum question would be a question of static friction, because in every question that you see here it was maximum length you had to find out. Here you look at the blue part, you had to find out the minimum value of f, maximum, minimum. You look at the previous question, minimum value of force, static friction. Previous one, okay, it was not mentioned minimum. But in most of the cases, wherever you see minimum or maximum, that is an indication of the question being a question of static friction. So solving this, you should get the maximum value of y for which the chain can remain on the table, and the value of y that you are going to get from this, you will get a inequality like this: y is less than or equal to mu L divided by 1 plus mu. From there, you can find out the maximum value by equating it. Y max will be equal to mu L upon 1 plus mu. Whatever questions we are doing, beta, if you can remember their results, even if we don't remember how we are solving it, because the results that are going to matter. Remember, static friction is one of those topics which creates a lot of doubt or confusion, but this is how it is. I can't change the nature of the question because it is like this. Okay, so that finishes this question. I'll give you 2 minutes and then we'll move on to the last question. And this last question would be looking familiar to you because I think we had discussed this question and I told you that we will do it when your friction is over. Have you noted this down, everyone? Do we understand what has been done? Whenever static friction comes, we don't know the value. We only know the maximum value of static friction. That is equal to mu s into n. Everyone got this? Remember, static friction is one of the topics which is tough. So don't worry about it. It's tough. You might find a bit of difficulty. The only way you can solve this difficulty is by doing a lot of questions, which I hope that you will do. Last day only I was praising you and this first year students are doing exceedingly well. I should not praise anyone. That is a wrong thing that I do. But as soon as I praise someone, dhum, dhadak, dhum, bhum. It goes that way. Once upon a time, I was praising NEET students and they go dhoom, dham, boom, bhum. Then I started praising this, they have gone doom, dhadak, doom, bhum. So now I will not praise anyone. Shall we move on to the next question? Yes or no? This is the last question, and I only give you 2 minutes to solve this. This is a question that I think we have already done. We were trying to do when I realized that you have not done friction. So this is the last one in this category. Question number 6 or 7 or whatever it is. Find out the minimum acceleration of the block A so that the block 10 kg does not fall. So I have a small block kept with a larger block and I'm pushing the larger block with a tremendous acceleration. What should be the value of this acceleration so that the block which is hanging, he does not fall? Just to remind you, I think how are we supposed to do this? Now remember, this block A is accelerating. What is the best way to solve this problem? From which frame of reference should I solve this problem? I can solve it from ground also. But the easier way for me is to sit on the top of this. Where are my hands? These are my hands. To sit on the top of this and solve this problem. So this green gentleman is the gentleman who is going to solve this problem. And as soon as he gets on the gentleman, he gets on the job of solving the problem, because the only reason why he has to solve the problem. So he starts to draw a free body diagram. He sees Mg, tongue, tongue, tongue. He sees a normal reaction and tongue, tongue, tongue coming from here. But then someone tells him, what does someone tell him? What does someone tell him? No one knows? Okay. I gave you enough chance. Someone tells him that he is on a accelerated frame, which is a non-inertial frame. So he must apply a pseudo force. I hope you remember this hero pseudo force. And this pseudo force will be in the backward direction, because your acceleration is in the forward direction. So apply a pseudo force m into a in the backward direction. From what I see now, there is normal reaction here, there is ma here, there is mg here. No one seems to be stopping this block from falling down, unless I think about my new friend, which is static friction. So now static friction will act and try to stop the block from going down. This block is not going to go jig, 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 like this, jig, 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 jig. So I have the blue equation ready. And the blue equation is N is equal to MA. That is the blue equation. Now, the condition given in the problem is such that the block should remain stationary. That means it should not go up and down. So I have the pink equation coming up. And the pink equation is Fs is equal to mg. So I again get the value of mg. Fs as mg. What should be the next step? We have done that step so many times. What should I do next? Anyone? Anyone knows how to do it from here? Please raise your hands. Okay, no one knows. So this static friction should be less than or equal to limiting friction. This limiting friction I know is fixed. That is mu s multiplied by n. So I get my equation Fs, which is equal to mg, should be less than or equal to mu s multiplied by n. Mg should be less than or equal to mu s, and n is equal to ma. So I get this equation, acceleration should be greater than or equal to g by mu. Again, you see this term minimum acceleration. So the value of minimum acceleration will be equal to g by mu. That ends this problem, and that ends the topic of static friction as well. The next class we will be beginning with the next chapter, which is work, power and energy. I would request, if anyone would listen to it, to go back home and try these problems on your own. If you can find time from your busy schedule, please do it. Or if you can only do these 5 or 6 questions, that are more than enough, that you have to prepare for your JEE. On that note, I will end this class. Take care. God bless all of you. Bye bye.